Okay, I think we are live now. I will, as usual, tweet the URL and we can get started. There we go. And I can see we are also live on YouTube, so perfect. I think I can start a bit with summary of where we are since last time. Last time I created two more symbols for the schematic. One was the RAM, and I said I'm going to be using one chip because it makes it easier for routing. Like I don't have to route two of them, and that still allows me to have up to 1 gig, which is the maximum this chip supports anyway. I think I'm going to start with 512 megs just because cheaper, obviously, than 1 gig. And I think that should be enough for my use case. I could actually go also lower to 256, but then it will depend on how much RAM I want to share for the graphics memory. And I'm not sure exactly how much. If it's like 128, then if I use 256, I will only have 128 megs of RAM left. So we'll see how that goes. I will just need to try it out and see. But yeah, this will be one RAM chip. And then the other symbol I created was for the red bean, which is a module that has Wi-Fi and Bluetooth. And the Bluetooth is over UART, the Wi-Fi is over SDIO. So we can have some connectivity. And yeah, this is where we are. Here we have, let's see, 4, was it parts? Yeah, we have the CPU, the RAM, the connectivity module, and here is the PMIC. So I will start by separating this into, putting it into separate sheets. So we have this one here, and let's create one. There we go, and this will be RAM. Interesting that this one has a 0, this one doesn't. Yeah. There we go. I thought there used to be the dimensions also here, but it doesn't matter. And then in the RAM sheet, we will have these two. So I cut it and I paste it. It's that simple. Furthermore, like I mentioned in one of the streams, there is a nice, well, it's kind of a no-brainer, but somehow I didn't think about it. So there is a nice trick you can do if you know that your schematic sheet is gonna be very long but not very wide. And that is, you just set the page to be in portrait mode. I mean, I have no idea why it never occurred to me, but I mean, this makes it so nice. I will do that. Let me just check one thing. Sorry for that. Just wanted to see the tweet went out. It has, okay. I guess people will join. So, yes, so this was designed so I can just connect things mostly yeah, with straight lines. Mostly, obviously, not everything, but there we go. So here I can copy this one. There we go, that takes care of that. We have the two, although there will be more. There will be more to those. I need to put termination on them. Right, that's fine. No. I'm gonna move these away here because I might need them later, so there's no point in removing them if I have to put them back again. Yeah. That takes care of that. And right, I'm missing some documents. Luckily I have the chip page open here, so that's good. Like I mentioned on Twitter, I've been looking a lot into how to connect and how to route the RAM. And there are so many resources on the internet about this, and like which one should you follow? But obviously it only like came to me after a while that shouldn't I check the page for the actual chip? I mean, there are usually application notes, and of course there are. So there is a there is a DDR guideline for this exact chip from STM, and you would assume they know their chip, so that's probably the one I will follow. So there we go. And there we go. I will also probably look from time to time at the discovery board schematic, just because I think it's really useful, or like it's a good resource. Yeah. So here we are on the STM side, and these pins. Actually, let's start with this. We have some introduction. Actually, really, I can recommend this document. Oh, Bleep Track! Hey, woohoo! New stream. Thanks for getting excited about this. Yeah, I really recommend this document because it explains it in, I think, a very approachable way. What to keep in mind, how to connect things, how to route them. There's some really good things here, like it explicitly says, like here, 10K pull down on reset, and similar with the ZQ and CKE, like it explicitly says what to do. But some documents, I don't know, they're not that explicit. You have to dig deep to find these things. So let's see. Same with later with routing. It explains how you should isolate the traces for signal integrity, what rules to use. This is quite interesting because STM, let me zoom in. STM recommends using this switchback pattern instead of the serpentine pattern, but I don't think KiCad supports this switchback, so we will probably just go for the classic meanders. It is preferred, so it's not like it's not gonna work. I mean, there's so many boards that use this. It's just yeah, I think they explain it actually exactly. Serpentines provoke or orthogonal propagation which compromises signal integrity. So I'm sure they're right, but in that case we can't really follow that because the tool doesn't have the functionality. But I think that's gonna be fine. There we go. And same here, they explicitly say for 4-layer boards which layers should be which signals, which is also really useful if you are a beginner, which I am kinda, so really good. They have some examples. They how to put capacitors, and I think they even have information for both if you want capacitors on top or on the bottom, which I want them on the top because I want to use this board later for the portable Linux board, which has the screen and keyboard on the bottom, so I don't want any components there. This is really useful. Exactly, which isolation rules and all the rules for the length. This is gonna be really, really helpful later when we're routing. Need to go through this. Oh, okay. So the part actual part how to connect in the schematic. I thought that was in this document, but apparently it's in the this one, getting started with hardware development, which is also really good. It has schematics for each peripheral, how you want to connect it. They also have recommended chips for EMI and ESD protection. Of course, all of those are from ST because ST, why would they not recommend their own chips? So let's just jump directly here. There we go. So we're just using the one chip, so we are good. CS connects, like everything connects pretty much directly, so that shouldn't be a problem. We have the differentials. Too bad KiCad doesn't have some native way to show differential. Just that something should be routed as differential signals. Okay, so reference. See, this is perfect. This is so good. That's LPDDR, so that's not for us. Yeah. Oh yeah, this for the SD card. It's really nice here on the next page. I mentioned on Twitter again this level translator from ST, which is designed for SD cards. That it has integrated EMI, ESD, and the pool resistors needed in a really tiny package. So it's really nice part, and I think I will use it. So I am not yet done with creating the symbols, that's for sure. Then we can go here. I'm fairly sure we will see the same. Exactly. So on the chip side, on the CPU side, we have the VREV going 100 UF to VREV DDR, which actually, I'm not sure if we have a power symbol for that. Let's see. There are mem. Yeah, there's a mem. That's quite interesting. DDR, there's probably no. So I could create more symbols for these power flags, power symbols, which I probably will do because VMem, I think I kind of like it named DDR to keep it consistent. So let's do, or actually, together with this one. Yes. Exactly. So ZQ. So resistor. Was that a resistor there? Oh, where is it? Ah, this. Yeah, 240 ohm, 1%. So yeah, do that. There we go. To ground. Perfect. %. I heard some people say it should be 0.1%, like for these references for these differential traces. They really recommend using precision stuff. Yeah. There we go. I'm also a bit peculiar about my label placements, so I will spend time on that because I think it's worth it for readability later. Yep, that's one. How many left to go? I'm not sure. Yeah, for these ATO, DTO 0 and 1, they are not referenced here in the what is it, in the discovery board. They are just connected to test points. Not sure exactly still what they do, but let's just do what we know and then later we can look more into it. So all these also connect here, but let me just, yes, but I wanted to actually rename them like this. Just for the consistency, and then right. I actually did put a note here that I want to rename these also to match that what I have here, but we can do that later because it's the most exciting. I will just leave the note and do that at some other point when I'm maybe creating more symbols. Yeah. Oh, I'm looking at the LDDR, but it doesn't matter in this. Yeah. Then we have the reset, which is there it is, with a pull down to 10K. Interesting. We can put it on this side maybe, because there's more space for that. ZQ was going. So this whole thing. There we go. Let me just move. So just in case you are not aware, normally when you select and start dragging, as you can see, the traces get disconnected, but while you're dragging, you can press tab and that actually keeps them attached. So that's really useful if you're like in this situation, if I had to redraw everything, or actually I would move it to the right and they would end up being in the middle of the pin. So that's really annoying. And this is a nice quick way to fix that. So yeah, there's a little trick for you. Actually, that's way too wide, at least for now. Although, yeah, let's see, because I might have to place them the other way around because there will be a lot happening here between these two. Maybe it makes more sense to actually have that connection. How do they do it here? I should close off some of these because I have just too many. All right, they don't do that. Where? There. Yeah. Yeah, so they do it like that, so that's all right. Except, yeah, they have these pull-ups detached, which that gets a bit confusing. So CKE, which is somewhere there. Okay, so that one has a pull down also. So we can do that right now. Yeah. Let's see how I want to do this. I could move here. I'm a bit, oh, okay, my NCs. Okay, let's move that out and move this back in. And that's just busy work. But I think we fixed that quite fast, so that's all right. I'm a bit not scared, but I don't know. Because I would like to edit this one so I can actually move this down. I can put the resistor here and then move this one here. But I've seen KiCad go a bit crazy when you edit symbols that have units, because then they kind of lose the connection. Do you know what? We are saved. So let's try that. This is what I actually usually do, that as I am connecting things, I actually edit the symbols just so it's easier to route them. So that's why it's hard to use sometimes symbols that are built in, because symbols are a bit of living creatures. Okay, let's see. Okay, we survived. Yeah. So off by one. There we go. Then, oops. What the heck happened there? Right. What is my grid? Oh, that explains things. Yeah. Then what is my grid in here? It's good. I'm not sure why the grids changed there. I thought I did this on the last stream as well, so annoying. But now we can do this. Ah, I had it right there. Yep, this is what I will do here. Oh, that was CK. Yeah, I moved them around. So yeah, I think that makes it clearer the cost of moving some things around, but again, I believe it's worth it. So how much can we move this one? One up. That's not enough. So these will have to go down to one up, down by 2. There we go. Uh-oh. Now I can select. Isn't that fast? So I think if I go out and nope, can't click. Yeah. Sometimes going in and out of the sheet helps. Not in this, not this time. Oh wow, still. No, there it is. Okay. But one more time. And again, I can't select. That's just amazing. Okay. Perfect. So CKE has a pull down. Reset has a pull down. Quite interesting that they are pulled down by default. So it's the chip that has to pull it up. I mean, that means that the RAM is actually reset all the time until the chip, the CPU pulls it up. Oh well, that's how they want it. Yeah, so the ZQ are actually not connected together. Is that seems odd, but that's how it is, yeah. Okay then. And the grounds, yeah, they are connected together, so we are just gonna do this. There we go. Now we're getting somewhere. Hi, tiny LED matrix. Where was I? Yeah, I was saying we're getting somewhere. So what I would actually usually do in these kind of things where you have a nice drawing, I would print this and kind of draw some comments or actually cross things out that I already done so I can keep track. But this is fine too. So we've done this, that one. Then this is done. Then for VREF, we have the 060. Which voltage is that? That's what I'm curious about. I think that's the one from the voltage divider. Let me close this one also for now. I just have too many. And it's annoying. That one I also need. Yeah, okay. Now we have just the two. VRFDDR, I think there was a voltage divider on a different sheet. Oh, okay, never mind. But between, exactly, 100 ohm differential means that you put the 100 ohm between them. So let's do that also. Should I sacrifice even more space, or how would that look? That would put this one here, because I would do it like this and then just move everything down, so this is exactly between them. I'm also wondering if KiCad later will recognize that these are differential, because I think it expects underscore P underscore N or even M, but for now that works. So is this enough? Now I have to be careful. And I didn't select something there. There we go. Move that back in. That is actually too far by 1, 2. And I lost selection. So there's definitely a pattern when this happens. I don't know. Is this a nightly thing, or is this... How long has this been happening? Yeah, I think that clears it up actually. So yeah, I like... Some people might be thinking, why does it have to be so clean? But that's just how I like to do it, and I will take the extra time just to make it look good. So sorry if it feels like a waste of time to you. It doesn't for me. I mean, this is designing. This is a design process, so it should look good, not only function but also form. If you don't agree, I'm sorry. So these two we have. Now we have that one. There's the termination. Do we actually need that? Yes, we do, and it's right there. So that's cool. Let's see. I could actually remove all these from the symbol and make them see inside the symbol and then invisible. That would get rid of all this space. But it's also good to have them explicitly like this. Yeah, I also think clean is better. Especially since I will copy a lot of this later into the next project, so I don't want to be confused later. I mean, it's like with code, this is comments without comments, like make it clear. Yeah, where are those? VDD, no, that's the reps, that's these two. let the what is it called? Let the decoupling begin. Oof, now I'm gonna start a thing. Oops, that's wrong. But should it be 100 nano or 0.1 UF micro? And I think I made a poll on Twitter some time ago, and more people voted on 100, I believe. But it's my schematic, so it is that. Nope. So sorry about that, but it is 0.1. And I don't have a good excuse. Again, I just like it like that. Is that a good enough excuse? Same will be done here, won't it? PDR, PDQ. So they are connected together and they go up here to VDDR, VDD, DDR, VREF, DDR. But VREF, let me find that here. Anyway, what's happening in the chat? Not much. What are you guys doing? Just chilling, listening to my commentary, my KiCad struggles. Okay, so that's where that comes from. So, now I'm in a bit of a pickle because for this to be nice, I need to move these apart, but for that I would have to change back to landscape. If I'm change to landscape, there might be not enough space vertically. Oof. Maybe it's all right. Let's get here. Not this. Wait. Oh wow, that's a bug for sure. If I drag with tab, the non-connect symbols are left behind. See, like if I select and just drag it, that's cool, that's cool. Then I press tab, change the mode, and they're left behind. So that's a bug. And that explains why they didn't move last time. I didn't pay attention. Eating, that's cool. Yes. PDR VREF. That's on STM part. It should go there. The strange thing, oh no, it actually is, okay. But I was gonna say it doesn't flip the capacitor, but it actually does flip the capacitor, and that's why, well, why it ends up being flipped. I think capacitors in this design might go to 3 digits, so this might be not enough space for it later, it overlaps. But let's deal with that when we have to deal with that. DDQ, actually not here, is it? It's this one. And that just goes to VDD, DDR. Wow, that's like tongue twisters. Eating pasta, cool. Enjoy your meal. Thanks for choosing me as your meal entertainment. I mean, seeing me fail at KiCad, that's some kind of entertainment, I hope. Yeah, I think this is... I should have started actually with the PMIC, because then I would know which voltage symbols I need. Because do I want to just copy these? I mean, I could start with copying them, and then if later I found I don't need some of them, I just merge them. So a really super simple change. Super meal entertainment. Woo! Yep. Yeah. Let's do that. What did I do it last time? I promise this will be quick, so don't get discouraged with me creating more symbols. Power. Power is here. Then we create a new. New. Power extra. Boom. And double check that it was added here correctly. It was perfect. Then yes, that's how I did last time. I can just make a copy and then DDR. Yes, and there it is. And I have to, what was it? Correct, that's correct. In one. Yes. And I think that's it. That will now, the net, because power symbols are a bit in strange. But I think the net will not now be, it either takes the name from the actual pin name or from the symbol name. So we're good. And then I can just make that a few times. So creating new power symbol is actually really easy and fast. So, you know, you can do that and then later erase them or remove them really easily. This one. And what else do we have? It was VDD ref, wasn't it? VDD core, VDD. What I saw ref before was DDR ref, wasn't it? Right here, VREF DDR. Why? Why not DDR VREF? Or I might actually change some of these later to actually say the voltages, like 1.8. I think that's clearer in some regard. But yeah, let's see later. It's not a big change, hopefully. Okay, that's those. Gosh. I guess it makes sense if you have many VREFs, then they will be next to each other, like alphabetically. that's a good one. The PMIC, that's a good place to check. Yeah, like that's kind of silly, like VDD core, but then 3.3. Why would you not just have the actual voltages? At least up to some point, because like some of them are specific for the peripherals, but otherwise I think it makes some sense. VTT DDR, sure, why not? I don't want to end up copying too much just blindly, because then you don't learn as much, but I think just learn by doing, by screwing up. That's one way to learn, I think. Yeah, I guess that's enough. So let's just delete that one. Perfect. Back here. So this one I can actually DDR here. Alignment things. Yes. And I think I should double check this, because now I'm doing too much without being sure. There it is. So on the RAM, that's here. These two go there. That's correct. The VREFs, yep, to VREF DDR. Perfect. 0.1.1. Super cool. That's correct. Ground is grounded. Reset is a pull up on that side. This order now doesn't match that other order, but that's fine. Or maybe I change. So PKE is on bottom. Okay. So now what I will do is, let's see, I guess I will just extend this whole symbol. 1, 2. I'm pressing the wrong button. One more, I think. Okay, that looks all right. Now there's a bit of a mess here. Hopefully we can fix it. Mostly like this. There we go. Now this is all nice. Perfect. Yes. And I remove, move it. Should have been the other way. Doesn't matter so much. So we are, as I said, getting somewhere. Now I'm actually thinking I won't need these. Will I regret deleting them? Let's find out later. So, looking at this one, we are pretty good. Yes, I will go into those in a second. 1, 2, 3, 4, 9, 9 here. For the decoupling, I'm wondering if there's some nice drawing for that either, but doesn't look like. There's VTT. Same as here, yeah. I mean, I wonder which one came first, if they actually made the board first and then designed this, so it doesn't really matter which one I base it on. 16 ray. Ooh, 16. I wonder how these are placed, like on the actual chip, if I could use some resistor networks, because that's a lot of resistors. Oh, there's the 100 that I put here. It was hiding from it. Oh, never mind, that's only for 2 16s. That's why it's, or is it? No, they are there. Interesting. Hundred, 200, 200, but here it's different, quite different. So which one to copy, to base it on? Yes. I have to modify this symbol as well. Move it a bit. One, 2, 3, 4. 4 seems enough. 1, 2, 3, 4. And this. And while we are at it, I could rename these. Yep. This is wrong. There we go. Always good to double check it. And I can remove this comment now. Perfect. I don't know, I think this is fairly, like, I'm keeping it readable here. This proportion is not very nice, but what can you do? All right, so that part is done. We have that. We will take care of those later. I guess we do these on one of the sides. Side has more space, this one. So it doesn't look like there's a good way to do it. So we just go for it. Do these have to be 1%? There's a question. Doesn't look like it. I believe they mark it if it's, or they don't. Okay, let's for now let's assume they are not, but later I can add it. And I think I should be able to insert this trace. Yep, automatically. That's really helpful. One too many. I mean, that's one way to do that. I think if I move it and put it back, oh, be like that. Now to verify, yep. Okay, they are connected. Sometimes I think, maybe not anymore, but it used to be that these junctions didn't always work somehow. I've seen it happen that you had to double check your junctions. Okay, give it even more space. That takes care of those, but there is more. Fast action, all of them. That is crazy. So these three, and then RAS, TAS, TS, TKE. Yep, all of them. Interesting. Yeah, that is what they say. Termination. There we go. That was pretty fast. Okay, I need to add a decoupling. More decoupling. But I'm a bit unsure which. 1, 2, 3, 4, 1, 2, 3, 4. Which guidelines to follow. And then these floating ones here, which do they connect to? I mean, some of them connect to the RAM chip and some of them connect to the STM. Although these actually, okay, these look like they have their own. Yep. Okay, that explains that part. So all these decoupling caps are for the RAM chip. Because if we check this, how many pins are there? Many. Just thinking how to fit them here. So that's gonna be really boring. So I think I'm gonna just do that later. Maybe even off stream because yeah. Okay, so that takes care of the RAM, and want to check. I think actually there is no label that has to come out of this sheet because everything is self-contained. These three right now they are not connected to anything, but let's worry about that later. I think it would be quite fun to actually draw the PMIC stuff. That one in a separate sheet. Hello. But I double clicked it. What the heck? What? Oh my. Okay, tiny LED matrix. Thanks for stopping by. How did that double click not work? We have the drawing for that here, but it's not very detailed, so probably I will just copy. We'll just copy this one. What do we have here? That's the USB Type-C. Why is this upside down? Never mind. That one is just for power, right? They have a dedicated USB Type-C just for power. I will not have that, so skip that. Right, because these are not used here, which is not so nice. I think the other board actually uses those. I mean, this is for the USB OTG stuff, so I would probably do that. Does this have the value? There it is. Okay, so let's just go for power. And I got this, paste it here. Let's try again. A portrait. I think this time around it will actually be more useful because it is only gonna be this one thing. And the 5 volts in, that is most likely from the USB DDR. So just feeding from here to there. Yep. 3 volts. That's also from here. Yes. 5 volts. Okay. So not much to it. Slow and steady. We have the 5 volt in for now. Again, I'm not 100% sure because they probably get it from. Oh, actually, it probably comes from here. Yeah, right. It comes from the USB. What is going on here? Right. I'm just thinking because I thought they maybe had it from like a barrel jack or power, but no, it's a dedicated Type C power. So can I just use 5 volt here? I wonder. I'm curious to see how did I do it in my STM board, in my SAMD board. Right, I just called it VBA. Yeah, the sheet is A3 because there was a lot here. Yeah, you know what? Actually, that makes sense because that comes from the USB bus. Yeah, I will do that. Good to listen to past yourself. And VBus is already there. So that's neat. Yeah, we've been going for an hour, so we can go a bit more. Let's see how long this whole thing takes. There's I2C, power on. It shouldn't take too long, so let's see. Especially since these are all same. I have to make sure that they are and not copy blindly. But yes, they are. All the buck converters take from 5 volt in. There we go. And then these I have to check a bit more because I do want the OTG to also be part. Although, how does this all work later with a battery? That's the question, because I want to be battery powered, of course, also, but that one is 3.7 and that PMAX didn't look like it had. It didn't look like it had a battery connection. I have to double check because this one was quite nice because yeah, it actually had battery, both charging and running off of battery. So it would provide all the voltages. Just boost it up here. But this, where was there? That means I'll have to do the battery logic myself. That's quite alright. I just need a battery to 5 volt buck, a separate buck, or maybe VBus. Yeah, again, need to read out on this. Can I actually from 3.7 to all these other voltages, especially 3.3, that might be a bit too close. Never mind. Later we can check. So here we have the DDR. With 10 here. There we go. 3.3. Perfect. And the 5 volt again, so we can just copy. And I know the one I just added is 1 micro, so let me fix that. And this is 1. Then LDO 2 and 5. 1 UF. How big are these? Oh, 4 2, yeah. But for the back, they're probably larger, and they, yeah, 6 or 3. That's all good. We will worry about that later. VN for the USB, isn't it? Yeah. So there we go. And VDD, which comes from here somewhere. Yep. That's also 3 volts. So, or at least, isn't it? I would assume so. So why have the two separate names? I mean, I know why. Partially, I know why, because it's two different sources of that voltage. So you need a way to differentiate between them, but that's okay. So here we actually come to something new. I need a label that will be going out of the sheet. And SDA is bidirectional. Pays off to actually set these. I know some people just ignore them and leave them inputs by default. But again, I think later when you do ERC, pays off. So power on, control, and then reset. Reset is bidirectional. Interesting. And now we can place them here. So I should actually do that. Saves me one click. And then we have a wake up. And then the power on key is an actual key over here, which I think I also want just for testing, at least for now. Later I can remove it if I don't need it. Because there is the wake up. And on the SAM, the wake up and the power, they kind of work similarly. But you know what? Add it. Switch small. Why do I always forget it? A small, we can find it. I seem to always forget what the button is called. Or it's actually missing. What the heck? What do I use this here? Switch PST. I was in between. Some cool options there, but this is quite right. And then we don't need to see this because we know based on where it's connected. There we go. Yeah. So good so far. Then on the other side, interrupt goes to the wake up pin. I see that already, so we can do that in a second. To zoom, I zoomed out of the page. Okay. That exactly. Link. The heck is a link? I'm not sure. So we have a small inductor. Right here. It's a very small inductor. Yep. Then we have the 0 ohm resistor for no reason, so let's just skip that. This is probably, so I would assume, for measuring current consumption, so you can remove that, and then you can put a multimeter there to measure the consumption. Maybe this is also the link one is for, but then Never mind. So what do we know about this one? It's a 1 microhenry, max. That copy now. Now let's for now just copy the whole symbol or whole name. Later I can find one to use. But this conveys all the information. It's easier than copying all that internal information there. So we have this, and then we have a cap which will not fit, but put it here. Shouldn't look that bad, I think. Or actually, if we do it slightly different, it will look pretty good. There we go. And that's the core. Perfect. Now I obviously know this won't fit here, so I need to move them. And I get annoying fast. 22, that's damn big. That's 0603, yeah. Okay. Then we copy this whole thing over here. So how much do we have to move it? 1, 2, 3. One, two, three. Put this away so it doesn't connect here. Okay, so that's not how we do it. Since we can't move down, go here. I think these videos would be more interesting if I later made a cut out of it, kind of with highlights maybe, because the whole process is fairly boring. So that's not so much fun over here for the watchers, for the viewers. Watch. That's something else. The problem is I don't know if I can make any cuts of the videos because I really don't want to listen back on these, listen to my own voice. It's gonna be really annoying. Okay. So I'm actually select one too far. There we go. These two, one too far. I think I'm moving at the bottom, doesn't matter. Save it. And then Perfect. Uh-oh. Will it crash? It did. Ah, shit. When did I save last? Crash counter 3. When did I save last time? I think fairly recently. Oh, not so recent. Yet. Just KiCad Live. Okay, we're back up to speed. That first load is always so long. Yeah, while we wait, we are now done waiting. You might have noticed when I reopened the project, it asked me, do I want to rescue some symbols? To be precise, this symbol. And the reason for that is because I edited the symbol, but the saved version of the schematic before the crash had a different version of the symbol because it was not edited. So usually in that case, you might want to rescue, quote, quote, the symbol, which means KiCad creates a new library with just that one symbol in the old version. This way, your schematic stays the same while the symbol, the new one, is still in KiCad libraries. I mean, you wouldn't want KiCad unexpectedly to change your symbol and maybe some pins were swapped. I mean, that would be really bad of KiCad. Also to randomly swap pins in their symbols, but it could happen for some reason. So that's why it asked me if I wanted to rescue. But I did not want to rescue because I wanted to use the new version and then just make fixes in my schematic. So that's what happened there. Let me save. And wait. Down. What is my grid? Correct. Grid here, correct also. Okay. I mean, it's not so bad. We didn't lose that much. So, yeah. Well, I got to talk about the rescue thing, so it was a teachable moment. So nothing got, lost. Well, except my few minutes of my work could have been a lot worse. So we're good. I'm actually curious, is that the exact symbol? Let's check Mouser. This stream is not sponsored by Mouser, it's just where I get my parts. If Mouser wants to sponsor me, I am open to negotiations. Let's see, how much is that inductor? I will probably get some cheaper ones from LCSC. Wow, that's Why did not autocorrect? That's clearly this. Oh, it's RO and it's R0. And I would assume that's a screw up on STM's part, because they all seem to have numbers there, so that would be really strange if that was a O. So damn, that's somewhat a lot. Let's compare just to be sure. Yep, 24, 4.3 amps, 3.2 amps. That's not quite right. 40 milliohms. 22. The footprint isn't it 2520, but it's right. Oh my gosh. Can I open this? Yeah. Wait, is that their that's their internal SVN server? Yeah, it's sure. And then it comes down to exactly the same data sheet probably as we have here. Yeah, so that was a bit pointless. So the links to data sheets are from the internal SVN servers at ST. And since they use Altium, Altium uses SVN for its schematic version control, which is something I think KiCad should look into, using Git for version controlling the schematics and like the whole project. I mean, I already do that myself anyway. Like I have Git open here and I keep making commits after each stream, trying not to keep the history. So why don't they do that? The 01, 4.3, that's the same as it says here. There's actually Mouser that has the wrong info, unless an action, but it's a, yeah. Right, I think that was exactly, oh, there's a D at the end of it. Okay, that's my bad. That's actually two different parts. Wow, that was easy to miss. Okay, so it is this part. Similar price. Yep. Okay. And I'm curious, what was the exact difference there? So if I go back, you can compare them. It seems to be only the current, at least looking here. Yeah, the frequency. Oh, the test frequency. Interesting. Doesn't matter so much. So what I try to do to cut a bit of cost is I order some of the like passives from LCSC, which is run by the same people that run JLC PCB. So when you order your PCBs, you can also order the parts and it's then shipped in the same package. You pay for shipping once. I think it's quite useful, and the page has gotten a lot better in recent time. Like you can see here, they have some pretty good categories, and then you can filter it. Not as good as on Mouser, but I think they're getting there slowly. So was it? Right? Yeah. 42. Hmm. I think that should actually change here. Like filter? No. Yeah, they don't think they will have Murata because they only have. Oh no, they do. Well, maybe then I should just look for that exact. Oh, there we go. Ah, but they don't have that exact part. They have some parts from that. I don't know, family, but not those exact. And that's too bad because see, it's 8 cents compared to what was it? I mean, I have it in euros, but yeah, that's a few times more. So, if possible, I order from LCSC, but not everything you can. Although I might not go with Murat, I might go with something else that has similar specs. But for now, oh wait, I already said this here. No, that should be a 0. There we go. And this went here. But yeah, I'll be the first to admit that sometimes it's confusing trying to find replacement parts because uh, if you don't 100% understand the significance, I mean, this is an inductor for a buck converter, but like has so many parameters, and which ones are important. I'm still not 100% sure what that resistance do in inductors. So is that value important, or is it enough if I just buy a 1 microhenry with like 4 amps? I'm not sure. I'm not sure how precisely I should match these specs. And that's just, I mean, I have some holes in my knowledge. I'm trying to fill them in, but it's not always so easy. But I think, right, since I moved, edited the part symbol, now it should be really easy to do what I was doing before we crashed, which is exactly this. Perfect. And then just need to replace these. There you go. Again, these I have to look more into. And for these, we'll probably have to move some stuff around again. There's the ground, which just connects to the regular ground anyway. That's kind of pointless. last one is just a decap. Apparently, because there's nothing connected to it. HDMI I'm not using, so these are not gonna be used probably unless the DSI needs something, some voltage. I haven't checked yet. Zoom. Okay, so VREF is VREF. Perfect. Then VTT. Perfect. Then let's just go for 1.8 because I really don't want to create a symbol for the audio. Skip these. VDDA I will use. That's good. And then right. USB. Perfect. And then some cups. But first let's save. I wanna get back with that again. And then we move VREF 1 down. Good. Then we move both sides. Need to remember that. And we move VTT 1 down and 1.8 1 down. Perfect. Except that came. Where did that come from? Actually, that was correct because when I moved, never mind. So now LDO3 1 down and LDO 1 down. Good. And 1 down. Perfect. And LDO 5, which is 2-part thing. That's gonna be a bit annoying. I'll fix that in a second. And LDO4 2 down. And that's like a whole thing over there. There we go. So yeah, it's hard to predict how you're gonna be, how much space do you need when you actually make these symbols. You need to kind of start connecting things, and only then you will know what you have to edit. But that's to be expected. And let's go back to grid. That looks mostly centered. What was That's not really any better. But let's do it like okay. There we go. Then we can add all the caps. And they are all different values. And I can't select anymore. Maybe I can. Oh, but it crashed. It didn't. There we go. Good as new. So for the VREF, we need one UF. For the VT, 10 UF. For the 1.8, 4.7. VDDA wants 4.7 as well, that's convenient. And this decoupling over here. That 4.7 as well, that's good. So, and then the last one is also 4.7. There we go. Okay, that's not quite done there. Save here first, and save here. We're back. Okay. So if we, oops, the next page. If we zoom out, we're actually skip that for now. Okay. Pretty good. That's a lot of it. I have to, again, let me leave notes for myself. So I need to look into the VBus stuff and into battery. And battery charging apparently, because this PMIC doesn't have any battery support. That's a bit disappointing there. Okay, but on a bit more exciting front, there we go. Now we get to import the labels that we put in the sheet. So SDA clock power on reset and yeah, I actually try to keep them similar like I do my symbols, so the inputs on the left, the outputs on the right. I mean, you can always move them around. It's no problem. Make it, you know, whatever works for you. Mhm. Like that. So now, let's see, PMake SDA, PMake SCL. The reset and that's wrong. Wake up. We have the PMake interrupt. Like perfect. And then I said the PMake is I2C4, so we can actually start connecting things. How exciting. I2C4. It is somewhere here and here. So here we go. And there we go. That's the first peripheral connected. And we don't want to forget. Let's move this out. No. The pull-ups on the I2C. Not that I would ever forget that. Yeah, that happened. Luckily, we can fix it on the PCB later, so that's oh, that's okay. We're closing in on 2 hours, which actually went really fast for me. And it's kind of too bad because I could actually keep going, but I think we should keep them. Yeah, like 2 hours seems alright, and also it's a weekday, so I don't want to do it for too long. So let's see what I can do after I add these. A good question is also what value should the I2C pull-ups be? And yeah, I've heard many opinions. I think 4.7 is quite universal, like it works pretty well. Like if you're gonna have long PMake lines, you might want to go lower, so the pull is actually stronger. But it also depends on the chip that is actually on the chips that are on the I2C, like how strong is their pull. And some chips even say in their data sheets how much the pull should be on I2C. I wonder if this one actually says. It's kind of short, so it might not. No. But yeah, I think 4.7 is a good value to start with, and later you can always replace them with 10K if you want to go with smaller pool, or 3.3, 2.2, 1K, but some chips actually can't go that, like they don't have enough strength, like current in them to actually pull if you're pulling too strongly with like 1K. So keep that in mind also. Like sometimes you might kind of screw yourself because you put too strong pull-ups. The PMake end. Where is it? Where was it? On this board. That's not right. PA0. Well, that was, yeah, in wake up. PA0. It's here. I wonder if that's actually a wake up pin or is that just a GPIO used? Wait, that's here, isn't it? No, PA3 here. Okay, so that is a power wake up actually. So yeah, you want to use that one. Power. Yep. There it is. So that is the one we have to use. I mean, there are other, but I think that should be fine to route. So let's just go for that one, and it's all good. So that takes care of that. Gimmick wake up, that I would assume is just any GPIO PC13 here, so that's quite alright. We can double check. I'll wake up 3. An input, isn't it? So I don't think that's related. Where is the power? Is it, yeah, a separate power? And it only has the power, okay. Spins. No. There, but yeah, so that takes care of that. Still need to connect these. Okay, the power on, where does that go? Right. Power on goes to power on. Who would have thought? So we can do that really fast. And the reset is also there. So, yeah. So it seems like this will be the global reset, really. Oh, phew. But it froze again. Let's save it. So, boom, that is done. Power on goes to power on, which is here. And there's the reset. What are the reset core? The reset core is pulled. There's a test pad. Bypass regulator is just pulled down. Oh wait, that's wrong. Yep, here. Phew. Reset is connected to reset, which I already did. And the reset core, like I said, 10 nano to ground. I mean, sure, would be interesting to maybe read up on it, what exactly it's doing. Let's skip that for now. While we're here, now the power pins are not here, so let's check. Oh, they have a 1.5 pull-ups only. Wow, that's really low. I think 4.7 should do. I have a lot, like I have a reel of 4.7s. That's what I want to use. I think 4.7s would be cheaper than 1.5 because they are more popular. Yeah, we're starting to get somewhere, I believe. It's that one. Yeah, I think that's gonna be enough. That's gonna be it for today. We just passed 2 hours. Just for fun, we can run the ERC. It's gonna be so many things. Oh, I don't even have it annotated, so we can do that. See, so we already have 21 capacitors, and I barely started. We're gonna go triple digits fast. Yeah, 257 errors, or actually warnings. There's just one error. What is the error? To say, because it actually doesn't error list. Should be one, right? Because it's warnings. Yeah, whatever. So that's where we are now. This got a lot cleaner when I moved these huge chunks away. Like the LDO is here. We need to work on that one. RAM needs decoupling, but that's quite alright. I think we're getting somewhere. Yeah, next time, well, we have a lot left. Like we have to do the SD cards, we have to do the DSI, the USB, 2 USBs actually. Need to figure out the power, the VBAT stuff. Yeah, I should actually, let me add a note to myself. I should add some LEDs, of course, and add switches, like user switch or 2. Those are always nice to have. But yeah, then for the keyboard, how do I want to do the keyboard? I guess I will do it as just the keyboard connector connected to directly keyboard to GPIOs. I wonder, we have 2 viewers. Who is the other viewer? We usually have some silent viewer. Anywho, not to drag it even more than it needs to be. Done with your presentation. Congrats, Bleep Track. I'm done, I think, for today also. So yeah, that will do. We did RAM. We did power. Getting there. Then we have a nice drawer here. There should be text. With it. That's the wrong code. Seriously. Or maybe they shouldn't be. Only one selected. Oh well. Yeah. That is it for today. Hope it was interesting or entertaining, at least in some way. Let's see when the next stream will be. Maybe Friday? No, actually, no, not Friday. Seeing Captain Marvel on Friday. So Saturday, I guess. I will announce it on Twitter. Show myself. No, I'm good. Yes, so that is all. Thanks for watching. Thanks for hanging out. Bleep Track. Glad you did your presentation. See you around.